Hi guys and welcome back. In today's episode we're going to actually do some useful stuff with our turret in Unity where we'll attempt to make it lock onto a target and kind of follow it around and get it ready to do some sort of firing animation so that it looks like it's taking the health off of one of the enemies. Now there's a couple of things I should have highlighted perhaps at the end, but it's worth highlighting now. One is that I probably made a mistake with the scale, or at least rather I'd forgotten to apply the scale in Blender before I imported it into Unity. So you'll see now I've got them as 111. What I actually did was I went back into here, clicked on the object there and did Control A, rotation and scale. Okay, and then I did it, and then they basically exported it as an FBX again. Okay, so just do that. Make sure that apply transform is set, selected objects, and just click export FBX. So if you were seeing a weird looking scaling in there, it really should be 111. That's something that you need to do. The other thing I should have pointed out is which way the gun should be pointing. Now in the Unity world, in game engines in general, the confusing thing is that the X and Z axis are on the floor, if you like, they're the ground, and the Y axis points upwards. In Blender it's the other way, so it's actually X and Y on the ground, and the Z axis is the axis that points up into the air. You can see this here highlighted here. Okay, so from a Blender perspective, you basically need to make sure that if you press 1 on the numpad, the gun needs to be facing towards you and that you've applied the rotation. Okay, so as long as that gun's pointing towards you there, then in Unity that's considered to be this is forward in Unity. Okay, along the Z axis there. In fact, forward is towards your screen, if you like it, when you look at the game. Does that make sense? I certainly hope so. Okay, so the other thing I wanted to just quickly do was just to make this life a little bit more interesting, was add some grass. So in order to do that, let's go over to, I got actually some grass from when I was testing this from before. So let's just go to documents, not the OneDrive documents, and then Unity. Low poly defense, assets, and somewhere in here there's some grass. It's this one here, so I'm just going to drag that into here. Okay, and you can see we've got our grass here, and what I'll do is I'll create a grass material. I'm right clicking and then just doing create material. Okay, and there we go, they'll call that grass material. Lovely, and then just now that it's selected, I'll make sure it's selected, and I'll just drag the texture here and pop it into the albedo. And then what I'll do here is I'll create right click and do create empty, create 3D object, plane, and finally drag the grass material onto that plane, and it should change to that colour. Now it's a bit small. Let's just click on it and do F2 to rename it to ground. Move it down a touch so we can see all of our turret and what have you. About there-ish. Doesn't have to be too accurate for now. It's very shiny. Let's just go into the grass material and just get rid of some of that smoothness because it's pretty rough grass, isn't it? And then I think just get rid of some of the metallic as well. There we go, something like that. It's a little small. I want to make it a bit bigger, so let's just do that as well. Let's click on here. We'll set the scale to 10 by 10 by 10. I'd quite like these to be zeros, the X and Z. Okay, but you'll see now that everything's kind of scaled up ridiculously. It doesn't look like grass anymore. So what we can do is we go to the grass material over here, and just on the tiling here, just change that to 10 by 10. And you can see that matches the scale. That looks a little bit more like grass, doesn't it? It looks very lowly, doesn't it? Poor little turret. Excuse me. I am assuming that you know how to navigate around in Unity. It's mostly with the Alt button. So if you hold Alt button down and then left click, you can look around like this. You can, holding the mouse button down, you can pan around like that. Just have a look around, and scroll wheel to move in and out. Yeah, on the mouse button. Yeah, I don't know if anything else. So Control does that as well. I'm just trying around to see if anything. No, nothing. Doesn't look like there's any other options there. Lovely. If you were to lose where you were, let's just say you were over here somewhere, and you're thinking, oh, I want to select the base again and move towards it. What you can just do is you just press turret base over here, and if you just press F, it will remove the scene camera over to the object you have selected. All right. So this is all good. So what are we going to do? Well, let's take this slowly. And try and work out what we're saying here. First of all, let's think about what this turret needs to do. It needs to have a way to look out for oncoming enemies, and then when it's found one, or it finds one, it needs to lock onto it and start firing at it. So we need to give this sort of turret a kind of list of states. You know, does it have a target right now? Is it firing at the target? Is it without a target? Stuff like that, right? So it knows what to do each time this update method gets called on it, which I'll show you right now. So what we'll do is we'll add a component over here, and it is a new script, so we'll click on new script and we'll call it turret controller. Make sure you spell it right, because spell it wrong now it's a bit of a fiddle to change the name. It's not too bad. And I'll double click that. You'll see it's been attached over here. If it wasn't attached, you could right click and do create C# script here, and then once it's created, just drag it onto the turret inspector over there. But we actually did it over here straight away, so that's another way of doing it. Alright, so there's all different ways you can apply these components. Let's double click on turret controller and have a look at what this does. So we can see here we've got a couple of methods: start and update. Maybe this is obvious to you, but start is called once when the component is first created. There are a couple of other states actually. You can see here it's saying that it's called before the first frame update. So there is also a method called awake, which I think is called immediately once the object is created. I'm not sure. There's a subtle difference, but I think from your perspective now it doesn't really matter. And update is called every frame. So if it's 60 frames a second, it will be called 60 times per second. So what can we do with this? Well, let's just start off easy. Let's just see if we can get this thing to rotate. So what I will do is I will say transform dot rotate. I thought I could use, let me just quickly check the reference. Well worth checking the logic here. So it is yeah, there we go. So it's, yeah, so we say vector 3 up, comma, this is the angle. So we'll just say, let's initially just say time dot delta time. Okay, I know you're gonna ask me what all this means in a moment. I will explain it all. So let's just do Control S. And now if I go back to Unity and press play, I'm hoping you can see that it's very, very slow. It is moving though, it is rotating. Now why is it rotating on this axis here? Well, the reason it's rotating on the axis there is because I said the vector 3 dot up. So if you look at here, the up axis is, as you may remember me saying a second ago, is Y. So it's rotating around this cone here. This is a useful cone actually, because it kind of shows you what that means in terms of rotation. It's very, very slow, but it is turning. Is it still turning? Just about. So what we can do, let's just speed that up a bit, shall we? Let's have a method up here called public float turn speed equals 10. Okay, now let's just clarify what this time dot delta time means. Basically, this is saying the amount of time that's passed since the last frame ran. So if we're running 100 frames a second, then that's going to have a time of 0.01. Now the reason we want to go down this road of doing that is because it means it's consistent for a given frame rate. If some computers run at a really fast frame rate, then potentially if we ran kind of a set rotation, then it would rotate a lot more quickly. We really want it to be consistent, so by dividing it by the number of frames a second, which is basically what this is doing, we're going to get a very consistent turn speed. So rotation speed. You'll see this a lot. You'll see this value here a lot multiplied by various turns and velocities and what have you. So let's just click times turn speed here. Okay, so in theory it should turn 10 times as fast. So if I did stop that then, so let's just click on play. Did I click play? I know sometimes you have to click it twice. There we go, we've got a bit more speed now. Okay, so what we have here is a script that can do a job for us. It can rotate, which is great, but it's not really doing much right now, is it? What we really need to do is get to focus on enemies. So let's start thinking about that. But what we can also do, by the way, if I just click on the turret here, you'll see that the turn speed is now available here. So I can actually edit this in the editor here. Now the reason that is because I've made the integer, or the float rather, I've made it public. Okay, so because it's public, I can actually change it here. Now there is a slight confusion. If I change that to 50, let's say, and run it again. Okay, that's great, and you can see it's turning nice and quick. But if I go back into here, I'm thinking, oh yeah, let's just change that to 30 and save it. You might be fooled into thinking that that is going to make any difference whatsoever. So it is quite confusing, because that's not going to make any difference whatsoever. It's actually this here, this 50 value here that's being used. Something just to bear in mind. If you wanted to revert back to the value in the class, then you just click over here on there and just click on there's a reset. There we go. That should set it to the value that you've saved, which is kind of good, right? Okay, so we have our turn speed. So we need to start thinking about how this is actually going to work. And I'm going to take a bit of a big bang approach here, but let's start just by highlighting the fact that this is going to have a variety of states on there. So I'll create what's called an enum, which allows us to store kind of a list of sort of hard-coded values, if you like, that could be used for the different states. So we'll have an enum, and we'll call it turret states. And let's just have a little think. We're going to have a state that says something like perhaps patrolling, which means it hasn't got a target yet and it's just looking about. It's going to have a state called acquiring, perhaps, when it's acquiring target. How about that? Acquiring target, and then target acquired. Okay, so those are the sort of three states we're thinking right now. Patrolling means it's doing nothing. Acquiring target means it's found the target, but it hasn't locked onto it, and as the name suggests, target acquired does that for you there. So let's just, in the update method, well, in the start method, let's create a variable here, and then we'll put something in the start method. So we'll have a private. In fact, I don't think it needs to be private. I think you can just say turret states current turret state. Let's call it something nice and meaningful. Equals turret states dot patrolling. So it's going to be in a very basic state. You will need to do that so that we've got something to start with. All right. In fact, no, we don't do it there. We'll put that in the start method here. Current turret state equals turret states dot patrolling. I've done the equals twice. Let's get rid of that. All right. So we're not really doing much yet. But in the update method, what we'll do is we will have every frame. Let's just comment that out for now. Let's keep it commented out. What we'll do is we'll have a selection of if statements. So I'll say if current turret state equals turret states dot patrolling. We'll say we'll have a method and we'll call it patrol. And then else if current turret states equals acquiring target. Oh, turret states dot. And then we'll have a method called acquire target. And finally, let's just keep doing these ones. Else if, I know you could say else, but we'll just keep this current turret state equals turret states dot target acquired. We'll say target acquired. Alright, and you can see now that we actually have three methods there, that three calls to something that don't exist yet. So let's quickly do that. We'll have one called void patrol. Let's just try some of the features here. Let's just see if we can right click here and then say I thought there might be a way of executing it. There probably is to create the method. Quick actions and refactoring. No, I'm not going to do that. Let's just stick with this for now. I'll work out how to do it next time. So void patrol. It's not going to do anything for now. Void acquire target. And finally, void target acquired. Okay, so we're not actually doing anything. Okay, this is doing absolutely nothing right now. It doesn't do anything in patrol, it doesn't do anything in acquire target, and it doesn't do anything in target acquired. But that's okay, but we've got our states and they're ready to be programmed. Alright, so let's have a little think about what we want patrol to be. Now, what I was thinking patrol should be is some sort of where are we? See, there we go. Some sort of looking about and busying ourselves. So for now, I'm not going to worry too much about doing that, about kind of just sort of randomly rotating to different places. But we could do something funky like that. What I really want to do is have a way that this turret here is every now and again having a look around to see if there are enemies nearby. Now, we could put that in the patrol method. Perhaps we could just, let's say, we could do it every frame. Every frame we could look for enemies. Let's create an enemy now. Let's create an enemy now just so we've got one. We'll create a 3D object. A cube is fine. And we'll just pop him over here somewhere. And we'll rename him as well. We'll call him enemy. Let's call him angry alien. Alright, He is an enemy, right? The reason I'm calling him something different is just so it's a little bit clearer. And we'll pop him over there somewhere. Okay, so this guy here, when he does his look around, he should be finding that there's an enemy nearby, angry alien nearby, and kill it. Try and kill it. How does it know it's an enemy? Well, let's have a quick look at that. If we go to angry alien here, you can see we've got this tag here as untagged. So let's create you've got a selection of tags you can use, but let's add a new one. Under tags here, we'll click on the plus, and we'll call it enemy. And now, if I go back to the angry alien, I can click on tag, and guess what? There's enemy. So this is good. So whenever I create these objects, and I will be doing that in code, we can tag them with the enemy tag, and then this guy here can just search for enemies on the screen. Because you can imagine there'll be other stuff there, right? There'll be other turrets, bases, who knows, some shrubbery, perhaps some trees. We really want this just finding the enemies, not going through every item and then trying to lock onto a tree and start shooting at it. That would be bad. So we've got this nice tag here, and that's deliberately set up by Unity so we can do this sort of thing. Good. So we've got our beast over here, but how do we get this to look for it? Well, like I say, we could put it in the patrol method here. But what I'd like to do is introduce some kind of multi-threading capacities. We're going to run a coroutine. What does that mean? Well, a coroutine is something that runs in the background. Effectively, it doesn't run when update runs. It runs as a separate task, if you like. So if you've got a multi-threaded processor, which to be honest with you, everybody does these days, these updates can be running, but perhaps in another thread, provided everything is efficient. This method could be going around and double checking for other enemies, and then setting the state to a quarrying target once it's locked on. Okay, so let's have a think about how we're going to do that. What we should probably do is create a coroutine. They're called coroutines, okay, not my favourite name for them, but we will create a coroutine. And the way you set up a coroutine is you have to have this thing called an Ienumerator. Don't worry too much if that doesn't make any sense right now, but basically this is what gets returned from the method. All right, and it'll become a bit clearer as I go along. And we'll create the method called something like scan for enemies. I don't think it needs any parameters right now. So what we're thinking this is going to do. Now, why is that also? Oh yeah, because we'll need to return something. We'll return something in a minute. So what do we need this to do? Well, let's have a think. We're going to be continually looking for enemies, I guess, unless it's already got one acquired. So let's just have a little thing. So let's just say while true. So that means this is always going to be running. And we're just going to print something. Looking for enemies. Smiley face. Perhaps that shouldn't be a smiley face. Okay. Okay. So what we're doing. So that's gonna run a lot, because bear in mind this isn't part of the update method. This is once we actually activate this, it's going to run as often as it can. So we should think about having a way to just get it to pause so that it's not looking for enemies every microsecond. So the way we do that is a rather slightly confusing, but I guess one of the standard things that you just type when you're doing this kind of thing is you say yield return. Excuse me. Come on. There we go. Return new. Wait for seconds, and let's just say for now it's between it's a float value, so you can put how many seconds you'll do. So let's just say 5 seconds. So what's this doing? Let's have a little look. It's going to print looking for enemies, and then it's going to yield return new. And what that's going to do basically is it's going to return control back to the CPU to do other work. So this is really rather useful. So it means that other things can carry on. This turret isn't constantly bashing away trying to look for new enemies on the scene. So this is the kind of thing that you would use if you were writing a coroutine. Now we need to call it. We need to start it, and the best place I think to start that would be here in the start method. So let's just do that. 1 second. We're going for a method. Guess what it's called? Start coroutine. And then you put the name of the script, which I think I called scan for enemies. Yes, I did. Control V. Excuse me. It's mucking me about. Scan for enemies. I hope I've spelled that right. And semicolon, and we'll get rid of that one. Okay. So this isn't going to do much right now. We've got patrolling that doesn't do anything, right? But provided this starts up, we should see looking for enemies, and that should update every 5 seconds or so. So let's give it a go. If we click on play there, and then under here, we've got this looking for enemies, so it has printed it on the console. With any luck, it'll run it again. And again. Fabulous. Fabulous. Right, so now we've got our looking for enemies. Now we can start getting funky with this thing, right? So first of all, I guess it's probably worth pointing out that we should only really be doing this if we're in the patrol state. So let's just do this. Okay. So this is what I'll also say if brackets. And then just add some things there, and then we'll do this looking for enemies. So if it's not patrolling, we don't want it finding new enemies because it's already got an enemy that it's locked onto or it's locking onto, right? So this here is saying, right, only do it when you're patrolling. This, while true, means it's always going to run forever, this scan for enemies. If I put that line there, here, what would probably happen is it would come out of this loop at some point. Bear in mind, although this is a coroutine, it can still exit. So we want something that keeps it going forever and ever, hence why I'm putting it in this while true block. Alright, so let's try and find out where our enemies are. So this should be actually quite straightforward. If I can just remind myself how to, it's quite a lot of these things you just have to go and go and look on the Unity documents website. So, but I've got it down here in my code here. So we're going to say game object, and this is an array of enemies, equals game object dot find game objects with tag. It's a very useful method, isn't it? And guess what? That's going to be enemy, because remember we created that tag called enemy, and what that's done is that's going to go around and it's going to find all of the game objects. This is a class method, they call these, so you don't need an instance or anything like that. You just create game object dot find game object with tag. It should be game objects, yes, thank you, with tag enemy. Great. Now we should be just a little bit aware that, I guess, if this box was 1,000 miles away or whatever, perhaps we shouldn't just immediately lock on as soon as it becomes available. So let's just have a little think about that, and let's have a range up here. So let's just say public float patrol range or something like that equals 5F. I'm not sure that should be public, but maybe anyway. So that's saying we've got 5 units. I think that's 5 meters or something like that, right? So this is good. So we've got our enemies, and what we can do now is go through each of those and just to see if they are near enough for us to lock onto them. So let's go to here. So we'll say we've got our array here. So now we can do the for each command. For each, I think actually, enemy. Is it game object enemy? Yeah, game object enemy in enemies. Okay, sorry about this. Try and copy it from there. So what we're saying here, it's going to loop through this enemies array, and it's going to each time around it's going to give you a game object that's going to be called enemy. It's going to give you a reference to a game object that's enemy. Okay, and what we can do, and then we can also say if brackets enemy vector3 dot distance between enemy dot transform dot position comma transform dot position is less than was it patrol range? Found one. Right, okay. Alright, so let's put that here. Are we in the right place? Yeah, if current states. Okay. Okay, so what are we saying here? We double check we're doing a patrol. We say looking for enemies. Obviously we'll remove some of this stuff, or perhaps that it as a debug. This here returns an array of the enemies that are currently in the scene. this here loops through those enemies, and it does this rather funky thing here. So what have I just done? It said vector3.distance between enemy.transform.position and transform.position. Well, let's just have a quick chat about what that means. Every object in Unity has a transform. A transform is simply its position, rotation, and scale. Okay, so we can get that game object, and we can get its transform here and its position here, right? And by the same token, we can get our transform.position because the transform.position means local to this object that this is attached to. Okay, and then we can get the distance between the two. Vector3 distance is and say if it's less than the patrol range, which we set up here, there, I can say found one. Right, so let's just save that. Let's change that maybe to yeah, let's change to 1 second. Okay, and let's run it. It's saying looking for enemies. It can't find one. Now let's just move it a bit closer. Hang on, I'll just bring it round using the arrow keys here. And now it's going to say found one every time. Looking for enemies, found one. Looking for enemies, found one. And in theory, I guess. Oh, sorry. When I go away a bit further, it'll say looking for enemies again because we haven't changed its state yet. Good. Now, something to bear in mind perhaps is that we might get more than one enemy. Okay, so let's have a variable and we'll pick the lowest one, right? So let's just have a value of we'll say float current min distance, current enemy min distance. Right, that's possibly not the best wording I've ever done. And we'll set something silly like 10,000 F. Okay, so long, long way away. Right, and what we can now do is say something along the lines of. Well, let's actually assign that to a variable. We're going to say vector3 float distance to enemy equals, and we'll just grab this here. We're going to do that. We're going to take it out straight away. And then now here we can say if distance to enemy is less than patrol range, okay, and distance to enemy is less than current enemy min distance. Found one nearby or something like that. Okay, and what we can then do is we can say current min distance there equals distance to enemy. Now, the reason we do that is so that if we run it again, any ones that are further away, this is now the new value, but I'm going to set it to 100,000 just to be absolutely sure. All right, but of course we haven't got an enemy to target on yet, so let's just have a little think about that. We want to set the current turret state, don't we, back to a quarrying target, because now we've got our. Let's just do that. Let's do it there. Control C, and we'll just say found one nearby. Equals dot a quarrying target. Okay, because we know that even no matter how many enemies there are, after this is finished, it's going to be looking at the. I just need to be a little bit careful here. Is it possible that it could try and target one and then try and target another? Maybe something to think about. But for now, I'm sorry, I'm overthinking it. So we're going to change the state to the turret quarrying target. So we don't have an enemy to point out. So what we should probably do is up here. I won't put it as a public. I'll just say game object current target. Okay, and then that can stay as null. Do you notice that screen? Is that? Oh, it's just I thought my screen was going wrong there. Current target, and down here we can say current target equals enemy. Alright, so you can see what it's going to do here. It's going to say the distance to the enemy, or maybe you can't, I'll explain it. It's going to get the distance between the enemy that we've currently got through in our little search. It's going to check to see if it's within the patrol range, and it's also going to check to see that if it's closer or not to the one that we've already logged onto. Just so you know, if this isn't valid, it won't run this bit. This is called short circuit logic. So if this actually comes, if this doesn't work, then it isn't going to check this bit here. Okay, so we don't need to worry about that if it's not in the patrol range. I hope that makes sense. Okay, right. So now we have our situation now. So at the end of this, provided there's one nearby, it will have selected at least one enemy. It may have cycled through a few of them if they're all inside the. They all become inside the patrol range, but hopefully it'll pick the nearest one and lock onto that with this acquiring target. So, and bear in mind, this is only going to run if the state is patrolling. So if you think about it, this yield return new here, in fact that needs to be not there, that needs to be outside the if statement, doesn't it? Because otherwise it's going to, once it's done this patrolling, it's going to loop round. So basically it's going to say if it's patrolling. So if you think about it, once it's found one, this thing here is never going to, currently at least, never going to get run again because we've changed the current turret state here. But don't worry, we'll change that back under certain circumstances. Okay, so let's click, let's click back here and we will run it again. Let's just move that away. Click play. It's saying looking for enemies every few seconds. And if I zoom in there, I'm hoping it'll say found one nearby. And can you see now it's no longer saying looking for enemies, which is exactly what we expected because it's changed the turret state. Okay, and the acquiring target, bear in mind, doesn't do anything. Now, there's something to bear in mind here, is that what happens if this thing goes out of range? We should probably, under the same script here, deselect it and change it back to patrolling again. All right, so let's do this. We'll say else if, let's just click on that lot, turret states dot acquiring target or equals target states, turret states, sorry, dot target acquired. So, okay, and we'll do the same thing. In fact, I might just put on a new line. I might just do the same thing here. I'll say float distance enemy. But we can't say enemy here because there is no enemy. This enemy was set up in this here. But yeah, you can see, there you go. You can see. Why isn't that working either? Current turret state. Excuse me. Sorry. Yeah. So here we need to say, what was it? Current target. Okay. So this is saying float distance to the enemy equals vector3.distance current target transposition. Okay. So as that target moves about, it's going to move further away or nearer or what have you. So this is checking the distance, and we'll just say now, if distance to enemy is greater than patrol range, we'll say print target enemy went out of range, back to patrolling. Right, I know that we'll actually do some real funky stuff once it actually works. Okay, so and we will obviously need to do something along the lines of current turret state equals turret states dot patrolling. Okay. So we've got two things in the gap. One is it's patrolling, it's going to see if it can find any. The other one is, if I tell you what, if we are required, let's just double check it hasn't gone out of range. If it has, hard luck, we're going to lose it again. So this is a good way to just keep things, so that it's not always firing at the target when it's 1,000 miles away. So let's give this a go now. So I hope that if I click on play, sometimes you have to wait a second after you've done it. Right, so we can see looking for enemies. I'll zoom in, and it should say now, found one nearby, and now it's stopped, okay, because we were quarrying target, and let's just move it out of range. There you go, enemy target out of range, back to patrolling. It's looking for enemies again. I guess I can move that in. Found one nearby. So we're in good shape here. We're in really, really good shape. But let's have a little think about what target acquiring means. Acquiring target and target acquired means. Acquiring target for me means that once we've located it, it's going to start rotating towards it. Okay. Now this is a bit of a dark art, so we need to have a little think about how we're going to do it. We could do the following. Hang on, we shouldn't do that. Let's just stop that. I could just say acquiring target, and there'd be something like transform dot rotation dot look at. Hang on, let me just get this right. Hang on. Sorry, it's transform dot look at, isn't it? Current target. Okay. So, current target? What's it called? Current target, yeah. Oh, current target, probably current target dot transform dot position. Alright, so we have to look at a vector 3. So press Control S, right? So let's just do this and you'll see what happens. Hang on, let's actually just make sure I'm recording, which I am. So if I click play now, looking for enemies, and let's just pop it over here. Now, look, this is really good news. It is looking at their enemy target's gone out of range. I'll bring it back in. There you go, and you can see that it's snapped to it. Okay, let's just do that again. I'll just snaps to it. I don't like that, and once it goes out of range, it's okay when it's following it. That's okay, but when it goes out of range, it'll lose it. And then if I do that, it snaps to it. We really don't want it doing that. The other problem we're going to face is if I do this. Can you see? We really don't want it rotating on that axis at all. Okay, so there's a couple of things we need to do. This is why I've got acquiring target and target acquired. What we probably want to do for starters is make sure it only rotates on the X and Z axis. We don't want it rotating on the Y axis, this one here. And secondly, when it's actually acquiring the target, I want to make it rotate towards it. And when it's acquired, then we can look at it, if you like, do this bit here. But again, make sure you keep the Y where it is. All right, so we don't want that going up and down. We just want it going kind of rotating around that. Let's do that way here, rotating around like that. Okay. So let's start with the quarrying target. This is probably the more tricky of them, of the two, I think, probably. So, but let's give it a go. 1 second. Right. So what we're going to do is we are going to say, right, we need to be thinking about where we're going to be looking. So we can get that in. We already know what that is. Under here, under acquired target, let's just comment that out. We're saying we want to be looking at. So let's just put vector 3. Vector 3. Look at vector. So we could call it something like yeah, let's just call it look at vector. This is where we want to be looking, okay, and that is the current target. Current target? Why has it been a monkey? It's current target, right? Yeah, current target dot. Sorry, look at vector equals new vector 3. Sorry. Right, and then it's current target dot transform dot position dot x, and we'll just do that for the y and the z. Now what we're saying here, is, okay, this is where we want to be looking at, okay? This basically is saying this is the position where the current target is, okay? Now, what did I mention a minute ago? Do you remember? I said we don't want to be looking at changing this value here. It's just the x and the z that we want to be looking at. We don't want it looking up and down. So the way we can do that is we just say transform.position. So that's our position already. So basically, on the y-axis, don't change anything. Stay where we are. Okay, that's good news. So that should keep us pointing firmly. In fact, we could probably do this now. We can get it to snap to the target. Look at vector. Okay, now if we run this, let's do it again. If we just drag us across, it'll start looking. And now I hope, if I move it up and down, can you see that doesn't change? It stays the same on the y-axis, but it does change its x and its z rotation. Very good news indeed. Right, but again, it's snapping to it. Can you see that? I was just trying to show you. Snap. We want it slowly rotating. So we're going to use I think it's a slurp we're going to use here. Yeah, or maybe rotate towards. Let's try rotate towards to start with, see how we get on. Okay, so what we'll do, we'll just get rid of that one there. So the direction we want to be facing, and this is important, okay, rather than if we're going to snap to it straight away, we need to think about the direction that we want the turret to be pointing. So the way you get that is you say vector 3 target direction equals look at vector minus our current position. That's a pretty nasty one, isn't it? If you don't understand that, don't worry too much. Basically that means that we're taking away where the current enemy is and our position to kind of create, if you like, a sort of an angle of turn. Maybe that's the best way. How much direction we need to turn to get to the position we're looking at. Okay, so what we'll do then is we'll say along the lines of vector 3. Thank you. New direction. So this is what we're going to do here is we're going to say, right, let's just rotate this a little bit. So this will be our new look at point. Okay, so we'll just say equals, bear with me on this, vector 3 dot rotate towards. We need to tell it which direction we want the transform. What have we done? To rotate along. So we want to rotate along its forward axis. The direction we want it to face. And then we need a speed that we're going to do it. For now, let's do time dot delta time. You remember, so show that later on. I think that's right. Why is it not working in vector 3 dot rotate towards? Am I missing one? Oh, I think we need a last value at the end here as well. I don't think it matters. I think we just put 0f there. Yeah, the magnitude. Let's just leave that alone. I'm not quite sure how that works, right? So that's our new direction. Okay, you can see that we're going to rotate towards it just a little bit. Remember that? Okay, and finally, then we'll just set our rotation equals quaternion dot look rotation new direction. Pretty horrible stuff. So let's quickly try and break this down a little bit, and don't worry if you don't understand it, because to be honest with you, it's a lot of trial and error for me as well. We're saying this is our target direction, so basically this is the difference between where we are now and where we want to be looking at. So we're taking the two away, and such is the power of C# that you can actually take things like vector 3's away from each other, and that'll leave you with a kind of the remaining amount of turn that's required. This here basically says, well, let me rotate you from where you are now, your forward direction, to the target direction, but just a little bit. Okay, and this 0f is the magnitude, which I think we can leave alone. And then finally we'll say, right, fine, we've got our new direction, we've got our new slight turn. Let's use the quaternion, which will give us a rotation to look at. So let's give that a go. Let's give it a go. And that worked well. So let's make sure. Let's get it to stop, and then we'll bring it back in. Can you see it slowly rotating towards it? There we go. Good, good, good. That is rotating to it. Now we might want to speed that up a little bit. In fact, I think I've already got a turn speed, haven't I? Let's just multiply by that. I know for a fact it looked like it was turning a lot quicker, so let's make the turn speed something like 2F. Okay, good times. So that should turn a bit more quickly. But we can prove this maybe just by... We're still playing? No. What's happened there? packing in. Right, we'll go around here. Let's just try and make sure we are close. And then we'll click on the play now. I think the reason that was it was just jumping a little bit. Now turn speed seems to be very quick. Okay, let's turn that times turn speed. Let's make that. Oh, what was I saying earlier on? Let's just change this here. Turn speed is 30 there. Let's just reset that. I did click reset, didn't I? Did I save it? And then reset. There we go. Got 2 there. There we go. Right. So now again, if I run this, it should turn a bit quickly. There we go. Lovely. That's not what I wanted to move. Is that what I wanted to move? Looking good. Okay. So the next thing we need to work out is once it's it's rotating towards it, but how do we know when it's completed its rotation? So the way we're going to do that is we are going to check the angle between where we are right now and the object. Okay, and if it's close, I don't know, within something like 2 degrees or something like that, or 5 degrees, then we'll assume it's locked on and we can start firing. By the way, the lock-on method will probably just do something like what we did earlier on, this one here, so it will constantly stay moving around to it, so it won't kind of rotate towards it. So let's give that a go. So what we'll do, I think, in here is say if vector 3, and this is another method that we got on vector 3, dot angle our current forward direction and the target direction is less than what, 5 degrees? Oh, let's make it reasonable. 4 degrees. Let's try 4 degrees. We'll say print target acquired. And then we can say current turret state equals turret states dot target acquired. What's wrong with that? What? Current turret state. I put equals. There we go. Sorry, it should be equals. There we go. That's a comparison, not an assignment. Right. Okay. So we're saying target acquired. So now this won't get called anymore because the next state will be target acquired. So let's just do that thing that we just said here. Let's just snatch that, the lookout vector there, and just do that. Hang on. Okay, that's a bit dirty and cheap, wasn't it? But the important thing I've done here, you'll notice, is that the y-axis doesn't change. And now, once it's acquired, it will continue. It will look at it all the time, so it won't try to rotate towards it. It'll just keep it locked on. I think that makes sense because if the target comes past quickly or something, as it gets really close, we don't want it sort of slowly rotating. Once it's locked on, it's locked on. Right. So let's just click on there. Click on here. And click on play. And we should, I think, see it rotating towards it. And it's saying target acquired. And now if I do something like that, you see it is actually very quickly moving towards it, right? Which we would expect. And I'll just move it across. You can see it's staying on. There's no amount of speed there. Once it's locked on, there you're not moving it. But let's get it out of the way. And it's gone out of range. I'll just zoom it over there. And there you go. You can see it's got target acquired. Clever stuff. Now obviously we want target acquired to do a little bit more. At the minute, it's great that the target's acquired. So what we maybe want to do as well in here is just something along the lines of, say, maybe fire. What does that mean? Well, what that means is we probably don't want this firing every single frame. What we're going to do in a minute is either create some sort of particle effect or perhaps even some bullets that are going to pop out. I need to have a little think about what the best way to do that is for the next episode. I've tried a couple of methods and I want to give you the best looking one. So we're going to stop right now here. I think we've done a lot of stuff today. What I'll do as well is I will create a package for this, which you can download and have a play with. I'll give it a little bit of a tidy up. Let's get rid of some of these bits here, like for instance. Want our code looking good? Yeah, I think that's about all we want to do today. Maybe we want to make. There's no reason why we want to wait that for 1 second either, is there? Let's make that 0.5f, something like that, and perhaps some of these values like patrol range and turn speed. Let's keep them public for now, which means they're available in our Sorry, we're pressing play. Don't be mean. There we go. Which means they're available in here, but we might later on want to make them just remove public so that they're not visible. Because I don't. This is good for debugging, but I don't think we necessarily want to have access to them. What's this saying here? The reference script on this behavior is missing. Okay, let's just clear that. Let's make sure it's still working. Ah, yeah, I know what. It's interesting that it actually compiled. Once it's attached, it's going to start saying. Huh, I thought it would. Not you. You. Interesting. I would have thought this may be fire. Oh, it's removed it. It's removed it, look. Let's just get rid of some of this nonsense as well. Sorry, guys. So, let's just set that here and say maybe fire. Let's add it down here. Void maybe fire. Alright. Actually, I think we want to keep that uppercase, don't we? That's my Java background there, getting the better of me. Guys, thank you very much for watching. Like I say, I'll put this a link to the package so you can import this into Unity when you're ready. If you need any problems or any comments, whatever, please be sure to add them and I will do my best to respond as soon as I can. Once again, guys, thanks for watching. Always appreciated. Cheers now. Bye-bye.